Welcome to my channel Dr. Munshi Nasser Skilltone. In this video we are continuing the book that we are covering by Florian Heiss using R for Introductory Econometrics. The first chapter that we have covered, the introduction of the R programming and its basics. Now in this video we are going to cover the regression analysis with cross-sectional data. And as you know that in my previous video I have discussed that there are three types of data that we are going to use from this book. One is cross-sectional data, and then time series data, and then panel data. So gradually each of these chapters we are going to cover, explain the outcome of the results of regression analysis and how we are going to do it in the R programming. That I will demonstrate in this particular video. So let's get started. Today we are going to cover the regression analysis with cross-section data by Florian Heiss using R for Introductory Econometrics. As you know that the previous video, this book is based on the Introductory Econometrics by Aldrich, famous economist. So basically his book is the main theoretical background of our discussion, and this is the application of the book that we are covering, and it is basically R programming based book. So I have another hopefully in the next video playlist I'm going to do it in the same thing using Python, so hopefully that will be in the future. But for now we are going to cover today's video on the chapter 2, the simple regression model, and this is the chapter 2 of the book that we are covering. Okay, the simple regression model is very important. So before you start anything, as I told you earlier, that you need to start with the creating a R project, right? So if you want to start a new project, if you click the new project, let's say I would like to save this project, and then you have, when you click the new project, it will appear as a create project. So it will appear new directory, existing directory, version control. So I strongly recommend you to use the new directory. And like I said in the last video, that every time when you are using R programming, please use this as your a fundamental way or step of doing any analysis in R programming. Start with a creating of a project. For example, here as well as I create R in action, this is my project name. So I strongly recommend you to create a project first and then go to the R script. Start with the R script and then name the R script. Like for example, in this case I say Introductory Econometrics with R. So name that R script and then you start writing your code. Okay, so let's get started. As I told you, this is simple regression analysis. If I zoom little bit, okay, I guess it is visible to you, right? So it says that in a simple regression, this is a univariate regression. So regression analysis and these basics, I hope you can cover it from the Aldrich book, but for our discussion's sake, it's very simple regression model. Regression is nothing but to see, to check what the actual observation is all about and what we are estimating from that observation. So if a bunch of population and then you're collecting some information as a sample and you run a regression line, if it is a upward sloping line, so how does this line fit to your sample data? That's what it actually shows in your any regression analysis. So basically it says that the regression analysis we are concerning to estimate the population parameter beta naught and beta 1. These are the two coefficients of the simple linear regression model, which is y is equal to beta naught plus beta 1 x y u, which is the error term. And there are certain assumptions for the ordinary least square model, which we are now currently dealing with. So ordinary least square model, there are almost 9 to 10 assumptions are there, but fundamentally we are dealing with the 5 basic assumptions. And what are those assumptions? We are gradually look for from this chapter. Okay, so the first one that we are going to cover is how to calculate this beta naught and beta 1 x. Okay, this is very important. So if I can highlight the whole thing, that will be easier for you to understand. Okay, now here it says that beta naught is equal to y bar, which means estimated y or the dependent variable minus the beta 1 by multiplied by the estimated or the observed, or you can say the mean of the x variable. So we are going to see how we can calculate it using our programming language, as well as we understand the meaning of this beta coefficient and beta 1. Okay, so now there are two ways we can find out the calculation. One is the intercept, which is this one, and this hat meaning that estimated. The hat of over this beta is called the estimated. So estimated value is y bar minus beta 1 x bar, is simply because we just calculate the whole thing to find out the intercept value and the coefficient value. And the coefficient value calculation using the OLS regression model is covariance of x and y. Covariance meaning that how x and y, these are the two variables that we are concerning in a univariate regression analysis. Univariate meaning that where there is only one regressor. In this case we have only one regressor, which is x, and only one dependent variable, which is y. So y is only one dependent variable and x is only one regressor or independent variable. So the regression analysis, the OLS regression analysis, is covariance of x and y, which means how the dependent variable and independent variable vary together, the relationship we are looking at, and then how does it depend on the variance of the independent variable x. And that's what it says, variance of x, which means the variability of the dependent variable or regressor. So what we have to do, we need, if we can calculate the covariance of x and y, and if we can calculate the variance of x, which means the value of the variance, then we can easily calculate the beta 1, and same goes to beta naught. If we calculate the y bar, and also if we calculate beta 1 multiplied by the x bar, which means the mean value. So now we are going to calculate this, and in our programming language, covariance is a function and variance is also a function. So if we know the x and y, the value, then we can use the covariance function and variance function to calculate the value, and then easily can manually calculate the whole thing. And there is of course another command, straightforward command, which is linear modeling command, LM command, but that I will explain later on. Okay. And as I told you that this value, we are going to give an example. We just need to calculate the four statistics: y bar, x bar, covariance of x and y, and variance of x, and plug them into these equations. So this is what we are doing in this particular video. Okay. So in the simple regression analysis, in this model we are using the Aldrich example, CEO salary, and the return on equity. This is the database that we are going to do. So first thing we are going to do is, we already installed this package called Aldrich, but let's assume that we are doing it again for the sake of this video. Okay, Aldrich model, and control enter. Okay, so this will allow you to install the Aldrich package in your R programming session, which is going to happen very soon. So you just need to wait for a few seconds to upload the whole thing into your system, and then once you install the package, you need to call this package to your session. So how do you call this package? We just need to do a library. Okay, library command, using a library command. Okay, library. Okay, Aldrich. You see already suggested. So library Aldrich. So now this data set, or this book data set, is available to your system. So the equation here that we are going to do is, our dependent variable is salary, and our independent variable is rate on equity. So CEO salary and the rate on equity, this is the model that we are going to use, and we are using the data set CEO cell data. We already analyzed in section 1.6. we consider the simple section 1.6, meaning that this one we already calculated before, but we are considering this simple model. Salary is equal to beta naught, which means, how we are going to do it using this. So basically we first load and attach the data set, and then we also calculate the four statistics we need for equation 2.2. this is the equation 2.2, and then 2.3. so we can produce the OLS ordinary least square formulas by hand. Finally, so the OLS parameters estimator are calculated. So the OLS regression line is salary. This is the intercept value, and this is the value of your coefficient beta 1, 18.50, and then it should be multiplied by the variable or your regressor or independent variable ROE. So you're looking at this value using the equation beta 1, manually we are going to calculate it, and also manually we are going to calculate the beta naught, which is the intercept. That's what we are doing here in this particular video. So this is the first step that we're going to do. Is, as I told you, first you need to write down the data. So here data, you are considering what? CEO cell data. Okay, so CEO, here this already suggested because the data set of the already is already in our system. So package, we are using package Aldrich. Okay, so we are using Aldrich package. And you remember I make a within bracket quotation. It means that it is not a numeric number, it's a string or character value, this package name, and that's why I actually did this one. So now the data set is loaded to our system. Okay, so now we can easily attach this data set. Okay, like command with attach, I mean every time we do not mention this data set, if this is the case, attach col, this command meaning that we are whatever command after that we are using, basically it gives the our idea that the same data set is repeatedly coming in every actions that we are going to do, unless we de-attach the data set, and which we are doing it in the very last single command. So that's why we are going to give attach. Okay, attach this data set CEO cell. Okay, this data set. Okay, and if you'd like to view this data set, I mean if you are going to view this data set, so what you have to do, you can just view your data by CEO this data set, and if you just command, as you can see here, if I just make it larger for you guys, you can see that this data set is salary, salary per skill salary, sales, rate of return on the equity, and then we have, there are other variables inside this example, but we are going to just dealing with the salary, which means our dependent variable, and this variable which is our independent variable or regressor. So this is what we are doing. So we know the data set, we viewing the data set. Okay, so now what we're going to do, we calculate the 4 statistics manually. Okay, and this is what this video is all about. So how we can do that to calculate the OLS formula? So is COV, which is the covariance function. Okay, you can create an object, then put that information into that object, but in other way is directly you can give the functional command and calculate the value. It's more easier, that's why I'm using this way, but you can always go for object using R syntax and then this command to calculate the value. So either way is fine for any R user. Okay, so we are going to use ROE. This is the value, and then salary of, this is the value that we are going to cover. So this is our value 1342.532. This is the value that we are going to find from the covariance analysis. Now then again, the next function is the var, the variance, and variance of ROE. And as you can remember that I did not put any data attachment here because I already attached the data set up front. So every time I am using a new function R, in the R I do not use any data set here to refer. Otherwise, if we don't attach the data set, then every time whenever you are going for covariance analysis or variance analysis, you need to give a command, a comma, and then put the data is equal to CEO cell 1, which is mean every time you calculate any command you need to give the data set as a reference. But since we already attached this one at the beginning, we do not need to. This is the beauty of our programming. Okay, now we already calculated the variance, now we calculate the mean. Okay, so we calculate the mean of what? Salary. Okay, so we are calculating mean of salary and then we already calculated this mean of the salary, which is 1281.12, and then we are going to convert calculate the mean of ROE. Okay, so we already calculated this one. So now manually we have to calculate the OLS coefficients, and how we are going to do that. So remember the beta 1 hat and beta naught hat, the manual equation that we have seen in the model, beta naught and beta 1, that's what we are calculating from manually here. And how we are going to calculate it? Using this R programming, very easy software. So first you use the beta 1 hat as a object name, and then you calculate using the R syntax Then what we are doing to upper part is the covariance. You see, this is the formula, covariance of x and y and variance of x, right? So that's what we are going to do in up here. Okay, so covariance of covariance of, this is the function that we are going to use, ROE is, and the salary, okay, salary, and then divided by the variance of this is another function, variance of ROE, and then you control enter, and then if you just print this value beta 1 hat, or you just have to write down this value, you will find out that 18.50 here, 18.50, and that's what it's supposed to be, 18.50 in the equation. Okay, now the next one is to find out the intercept value. Okay, so intercept value is the calculation of this one. Intercept value, remember, the intercept value is y bar, which is the mean of the dependent variable, and the estimated value of beta 1 or coefficient, and then mean of your regressor. That's what we are going to find out for intercept value. So that's why we are again creating a new object, beta 0 hat or beta naught hat. Okay, then our syntax, and then we are going to calculate mean of our dependent variable, which is here salary. Okay, and then what we doing is minus beta 1, which is our first coefficient value that we already calculated just now, multiplied by the mean of our regressor. Here regressor is ROE, and then what we are doing is we are going to close this whole thing. Okay, if we are going to close this whole thing, just control enter. I mean, the data set is almost done, and then if we print this beta 0 hat, let's see what value comes out. 963.193, 963.193. So now, since our purpose is served, we already calculated the equation value of intercept and the beta 1, which means the coefficient value. Now our data set, we no longer needed this data set, so we detach the thing, detach the whole thing, detach the CEO cell 1 data, and that's what now this time you don't if you make any command further, the data set will not, we will need the data set for your command attachment, but because you already detached the whole data set. So this is the purpose of the whole thing, and the simple way of doing the same thing is, this is the thing, the LM function, which is the command of the linear regression model command, dependent variable and regressor x, and the formula we are going to use lm y, which means the dependent variable, then this sign of regression sign, and this is the regressor value x, and then you need to give the data set name, and that is the simple command for R programming. And throughout the whole chapters, whether you are going to do it linear regression, panel, time series, this is the kind of formula, it will repeatedly come every time you are using any regression analysis. So if we go for simple analysis, that's what we have found in the value by manually calculating it. So if we are going to do it simply, then the OLS regression will be LM regression going to go salary is our, remember our salary is our value, I mean the dependent value variable, and then we are using ROE is our independent variable, then comma data equal to CEO cell. This is the data set we are using. So I hope the command gives you the result. Intercept value is 963.2 and the coefficient value is 18.5. So basically that's what we have found in our other purposes, which we have calculated manually. So both the way we learn how to calculate our simple univariate regression analysis, which is ordinary least square analysis, using R programming language, very simply, very easily, and understand the meaning of the steps of the first fundamental idea of how to calculate the beta and beta naught, beta 1 and beta naught and beta 1 value of simple OLS regression model. So that's what we have in this particular video. We are going to cover the next couple of regression analyses and its assumptions and what happens if the assumptions are violated. We will discuss those things in the next video. So I'll see you in the next tutorial.